Greetings, STEM 1 students. Today's lesson is going to be on probability, and I just want to start with some vocabulary. When we talk about outcomes in probability, we're really talking about the way an experiment can turn out. So, like, for example, let's say you're flipping a coin. One outcome might be that you get a heads, or another outcome might be that you flip a tails. Um, if you were rolling a die, an outcome might be rolling a 6. Okay. So when we talk about a sample space is all the possible outcomes for an experiment. And, it's a list. It's a list of them. So if we were going to do the sample space for rolling a die, that sample space would be, they usually use like this little, it's called set builder notation. So this little bracket thing. And you would just list them. You could say, okay, if I rolled a die, I might roll a 1, I roll a 2, I might roll a 3, 4, a 5, and a 6. And that would be considered the sample space because it's just literally a list of all the possible outcomes. Okay. So a lot of times with probability, we're going to be looking at the likelihood that something's going to happen, but it can be expressed 3 different ways. So it might be that it's written as a decimal. It might be written as a ratio, and usually we're going to reduce the ratio fully. So if we get like 3/6, we would reduce it to a half. The other way you can see it written is a percentage. So it's going to be one of those 3 ways, and really none's better than the other. It's just a matter of what makes sense to you, okay? And it's really going to show us the likelihood of an event occurring. And so you can think about that a couple different ways. Some people like to think about it in terms of the sample space. So we might think of probability as the number, and I'll move this over so you can kind of space it on your paper. So one way to think about it would be the number of successes. And if you divide that by the total number of choices, or the total number of outcomes, that would be one way to get that ratio, okay? A success is, I'm just going to put a side note, success in experiments in probability really just means that the event ended, how do I want to say that? The event ended favorably. So in other words, like if we were trying to roll ahead, if we were trying to roll heads or flip heads, I'm sorry, on a coin. Gosh, you can tell it's been a 3-day weekend. That would mean that, you got ahead. Okay. Let's see. Another way you might think of this as for probability would be to maybe express it in a little different way. So if you look down below, this experiment has, I guess we can call it an experiment. And that sounds kind of weird, especially when we've been living in our science world with experiments. But an experiment really is just an event where we are looking at outcomes. So if we look at the way this is written, this probability example, if you look to the right, we have kind of what I'm going to call a sack of marbles. And in that sack there, we have 2 of them that are black, and there are 10 total marbles. So this P parentheses black really means the probability of selecting black. That's what that notation means. And in this case, probability of black would be 2 out of 10, which if you divide that would be 0.2. So we could either write it as 1/5, which would be the reduced ratio, If you divide it in your calculator, you would get 0.2. If you did it as a percentage, you would just move the decimal 2 spots to the right, so 20%. And any of those methods would be fine for expressing that probability, any of those notations. Just going to move this over a little bit. All right, so let's see what that would look like for here. Probability of not black. Well, if 2 out of 10 are black, that would mean 8 out of 10 are not black. And that would also mean if you divided it, that would be 0.8. If we did a reduced fraction, we'd get 4/5. And if we did a percentage, we would just take the decimal here and move it 2 spots to the right. So we would move that over 2 spots, and that would be 80%. I don't care which way you write it, but if you do the fraction, make sure you do the reduced fraction like this. Okay. Odds are a bit different. Odds are going to be representing, they're always going to be written as a ratio. So if you want to add that in here, you'll never see these written as a decimal or a percentage. So odds are going to be written in a different format. It's going to be the amount of choices that apply. And then I'm going to put a colon because they usually use a colon instead of the fraction bar. And then on the other side of that ratio, they'll say the amount of choices that don't apply. Okay, so looking back up here at the picture, the odds in favor of black means the first number we write down, this first number is going to be the number of items that are black. Okay, and then the second number we write down, instead of being the total, the second number we write down will be the number of items that are not black. So in this case, 2 of them are black. And 1, 2, 3, 4. Well, if there's 10 total, that means 8 of them are not. So it's not like the total number goes second. It's the amount that are not fitting this condition. So let me circle that. So we'll say this first number describes that condition. The second number would be the amount of items not matching the description. That's how odds work. Now you should reduce it if you can. So 2 to 8 would reduce, they're both even numbers. 2 to 8 would reduce to 1 to 4. Okay, so if we do odds in favor of not black, well, that would mean 8 of them are not black. 2 of them are. And if we reduce that, it would be 4 to 1. So that means for every 4 that are not black marbles, there's one that is not. Or there's one that is, excuse me. Okay, so I'm going to do a couple examples with you. We're going to jump around in your packet a little bit. It says identify the sample space. So I'm going to abbreviate. Sample space is just going to be a list of all the possible outcomes. So in this case, I'm just going to list everything you could roll. You could roll a 1, a 2, a 3, a 4, a 5, or a 6. Okay, and then the outcome in this case, the outcome would be what they actually rolled. And in this case, if you look at the picture, the outcome is just one of those choices, which was a 5. All right, number 2, spinning a spinner, the sample space. Sample space would be a list of all the possible outcomes. So we have A, B, C, and D. And again, I'm kind of using those squiggly brackets, kind of like we did with domain and range. And the outcome, I'm just going to abbreviate OC. Outcome would be what happened in this case. The outcome was A. That's it. That's all. It's as simple as that. Okay. Impossible basically means that there's 0% chance of it happening. Unlikely basically means it's between 0 and 50%, so less than half. Okay. As likely as not would mean that it's 50% likely to happen, 50-50 chance. Likely would mean between 50 and 100, not including those numbers. And 100% certain would be, it's 100% likely. Okay, so let's look at what's happening here. Selecting a green marble from a bag of white marbles. Well, think about that. If they're all white marbles, how many of them would be green? Well, that would be 0 out of however many items there are. Well, that's impossible. You can't do that. So this would be impossible, would be our outcome. You're just selecting which word from the list up above describes this situation. You can't do it. All right, choosing a vowel. Well, let's look here. We have 1, 2, and 3. We have 3 out of a total of 6 choices. Well, that's basically half. So there's a 50-50 chance. So I'm going to say that this is as likely as not. Basically, again, that means it's a 50-50 shot. Okay. So the next one, guessing a number from 1 to 3 when you have 2 tries. Correctly guessing a number from 1 to 3 when you have 2 tries. Well, if you think about that, if you got 2 tries, you got 2 chances out of 3. Well, what's 2/3 as a decimal? It's about 0.66. Okay, well, that's more than 50%, so I would say that that's likely. It's likely to happen. So we're kind of just using those ranges to figure out which category it fits in. Okay. On the next set of questions, if we're looking at choosing a yellow card, what we want to think about is how many total cards there are. So if they don't give you a total, I would find that out by just adding all these numbers up. And in this case, I'm just going to do some mental math. I know these ones add up to 20. And I know the inside numbers add up to 20. So there's a total of 40. So choosing a yellow card, well, it looks like there are 12 out of 40 cards. And if we reduce that, they're both divisible by 4. That would reduce to 3/10. Choosing an orange card, again, we still have 40 to pick from. It doesn't say we are keeping the yellow cards out. Each experiment is a unique situation. So choosing an orange card, we're looking at 8 out of 40, which those are both divisible by 8. So we can reduce that down to 1/5. Not choosing a white card. Well, 13 are white. So let's just subtract 40 minus 13 and see how many are not white. And in that case, there'd be 27 out of the 40 would not be white. 27/40. Not choosing a red card. So again, same idea. I'm just going to take 40 minus the reds, which in this case is 7. And that would mean if I added up all the other categories, 33 out of 40 of them would not be red. Okay. On number 10, it gives us the total amount inspected, and it gives that 3 of them are missing. So the experimental probability would be how many fit the situation. If it's missing a pickle, they said there was 3 out of 20 of those. So the experimental probability would be 3 out of 20. Okay. Now, what we want to do is just set up a ratio. So 3 out of 20, 20 is the experimental probability. Well, what they're giving us here is like a new sample space. So now we're saying, okay, if we enlarge the group of 20 to 300, how many out of that 300 would be missing a pickle? This is just cross multiplying. So we could say 3 times 300 is 900. Set it equal to 20 times x, which is 20x. And if we divide by 20, we get 90 divided by 2. I'm just doing some mental math here. That should be 45. So that would mean 45 out of 300 would be missing a pickle. Okay. 11 will work very similarly. I'm going to let you try one of those here on your own. I'm going to jump around a little bit. Let's go to the last page. Second to last page, I should say. On practice A, it wants us to find the theoretical probability. So if we're flipping a coin and it lands heads up, again, just think about total choices first. There's 2 choices. How many of those choices are tails? 1 out of 2. Number 2, choosing a yellow marble from a bag of 3 yellow marbles and 7 blue marbles. So again, you got to go total first. In total, 3 plus 7, you got 10 marbles. How many of them are yellow? 3 out of the 10. So it's always part out of total. Rolling a 1 on a number cube. Well, that's the same thing as a dice. Companies aren't allowed to write that down, okay? Well, die is, I guess, the singular version of it. But how many sides have 1 on it? Well, that would be 1 out of 6. Randomly choosing the letter A in the words math. Well, let's see. How many total letters? You have 4 total choices. And there's only 1 of those that's an A. Probability it will rain is 10%. What's the probability it will not rain? Well, if 100% is your total, this is just simple subtraction. 100% minus 10% would be 90%. Let's see, number 6. Probability of choosing a red marble from a bag is 3 out of 4. Not choosing a red marble. Well, if 3 out of 4 are red, that means that the other 1 out of 4 wouldn't be red. A spinner has red, green, and blue. The probability of spinning red is 0.2, so I'm just going to list that off the side. Red is 0.2. Blue is 0.3. What's the probability of spinning a green? Well, again, the decimals are just really like percentages, so this would be like 20% if you move the decimal over. 30% here. When we're in decimal form, these have to add up to 1. So I'm just going to put an X here. So if we add these together, this would be 0.5 plus X has to add up to 1. Well, if we've already used 0.5, what plus 0.5 would add up to 1? Well, that has to be 0.5. The decimals have to add up to 1. Okay, probability of winning first place is 5%. Probability of not winning would be 100% minus that, which would be 95%. Okay, odds in favor of winning the contest are 1 to 4. So this one gets a little tricky because the 1 is the win and the 4 is the losses. So that really means the total number of outcomes is what you get when you add those all together. So there would be 5 total outcomes here. You have to take the 1 and the 4 and add them together. Okay. How many ways can a person win? Well, if you look right here, we just labeled that. There's 1 way they can win out of 5 total choices. Oh, so they don't want the probability here. They just want how many ways. So there's 1 way they can win. The probability would be the part that applies out of the total number of choices. So 1 out of 5. Okay. With odds, you have to add those together to get the total. Okay, just be aware of that. The odds against the spinner landing on green. So against it means the first number is not green. So 7 of the spots would not be green, and 2 of them are green. And it looks like the total here is 7 plus 2 is 9. Okay, so the total number of possible outcomes, 7 plus 2 is 9. How many ways can the spinner not land on green? Well, whatever they said here, whatever they said, that describes the very first number. Odds always are described by that first number. So there are 7 ways to not land on green, which means the probability would be 7 out of 9. Okay. And then this last one is just working it backwards. So the probability of choosing a green marble is 3 out of 5. How many ways can green be chosen? That means 3 of those out of the 5 would apply. How many of them are not green? Well, if there's 5 total choices, 3 are green. That means 2 are not. So the odds in favor of choosing a green means I'm going to put the green ones first. And I'm going to put the not green one second, which would be 2. See how odds just don't have a total on the bottom? It's the other part that makes up the total. So if we write it horizontally, it would just be 3 to 2. Okay. The last question, probability of A just wants the likelihood that A will occur. So it looks like there's 6 of those out of a total of, if we add those up, what is that, 15? Yeah. So 6 out of 15, and I'm going to reduce that because they're divisible by 3. I'm going to get 2/5 when I reduce that. Probability of not B. Well, it looks like we have a 6 and a 5 that are not B. So 6 and a 5, if we add those, probability would be the part that applies to the situation. So 11 are not B out of a total of 15. Now again, this is odds, so that's different. Odds will be whatever they describe will go here. So this will be the C amount that are C, and this will be the amount that is not C. Okay, so it looks like the C category has 5, and if there were 15 total, that means all of the other ones, if we add the other ones up, A and B, added together would be 10, which should reduce to 1 to 2. And that's it. All right, your job is to finish the rest of the packet. Have it ready for tomorrow. Otherwise, you will be using some in-class time to get this done.